In this lesson, we're going to be talking about equivalent expressions. Our learning objectives are to know what it means for two expressions to be equivalent and to be able to determine whether two expressions are equivalent using substitution. Let's begin this lesson by going through a starting activity. So in algebra, like with using words, there are often many ways to express the same thing. Over here, we have a collection of pronumerals, my letters, and numbers that can be arranged into many different equivalent expressions. So as you can see here, I have 1, 2, 3 A's and 1, 2, 3, 4, 5, 6, 7 ones. Now, if I wanted to write down an expression which represents my collection here, I could say I have 3 A's and 7 ones. So literally just 7. But hopefully you can see that there are different ways I could actually write this. So this is where this statement comes into play. Just like in English, how there's more than one way you could say a phrase, so too with maths, there isn't just one way that you can express some mathematical truth. So right here, if I wanted to, I could say, well, this is equivalent to A plus A plus A, because I have 3 A's, so I'm just going to write this a little bit differently. And then instead of saying I have 7, what if I said I have 3 plus 4? These two statements, these two expressions are equivalent because they're equal. They mean the same thing. And you could write this another way. I could say I have 2A plus 5 plus 2. All of these expressions are equivalent because they equal the same thing. Let's now go through a formal definition of equivalent expressions. So two expressions are called equivalent when they are always equal, regardless of what numbers are substituted for the pronumerals. Let's now go through an example question. So here we have, are 2A plus 6 and A plus 6 plus A equivalent? Now, I think many of us would be tempted to answer this question by going, well, I have A here and I have A here, and I know that A plus A is 2A, so then I'm going to have this plus 6 here. Then I've got 2A plus 6 on this side, and obviously they're going to be the same because they're literally the same. We're not going to be using that technique in this lesson. We call this gathering like terms. I'll discuss it a bit later. But in this lesson, what we're really focusing on is using substitution to prove whether or not expressions are equivalent. So let's now use substitution to prove whether or not these are equivalent. So I'm going to say, let A equal 4. So I'm going to come over here, and in my A position, I'm going to put in 4. Then I'm going to plus my 6. Then over here in my A position, I'm going to put in 4 plus 6 plus 4. 2 times 4, that's 8. Then I have to plus my 6. On this side, 4 plus 6 is 10. Then I need to plus my 4. 8 plus 6 is 14. 10 plus 4 is 14. So as you can see, they both give me the same result of 14, which means because they equal each other in the answers, that means that these two are equivalent expressions. Now, if I really wanted to prove this, I would have to make sure that regardless of what number A is here, so it could be 89 or it could be 101, I need to make sure that for any value of A, I'm always going to get the same answer coming out. And that's what we read here. They're always equal regardless of what numbers are substituted for the pronumerals. So if these two are truly equivalent, no matter what number I put into my A, they should always be equal to each other. And we know that is going to be the case. Now, we can use a table of values to test if expressions are equivalent, and that's what we're going to be doing next. Let's now use a table of values to see if these expressions here are equivalent. Now, I see that the pronumeral that I'm using is A, so at the top here, I'm going to say A equals 1, A equals 2, A equals 3. Then down my left-hand column here, I'm going to be putting down all of these expressions. So I'm going to have 2A plus 6. Then I'm going to have 6A plus 2, 6A plus 2. Then I'm going to have A plus 3 times 2. Now I'm going to write that a little bit differently. I'm going to write it as 2A plus 3 because that's a nicer way to write it. And then finally 8A. Now what I'm going to do is fill out this table of values. Now if they are equivalent, they should all be equal to the same answer for when A equals 1. So all these should be equal. If they are equivalent, they should be all equaling the same number for when A equals 2. And so too for A equals 3. So let's now fill out this table. Okay, so let's begin. So if A equals 1 for 2A plus 1, well, I'm going to get 2 times 1, which is 2 plus 6, which is 8. Over here, if I put in 1 into my A position, I'm going to get 6 times 1 is 6 plus 2 is 8. Over here, if I put 1 into this position, it's going to give me 1 plus 3, which is 4, times 2. 4 times 2 is 8. It's going to give me 8. Here, if I put 1 into the A position, it's going to give me A times 1, which is 8. Let's now go through a equals 2. So again, I'm going to be putting this number into this pronumeral here. So it's going to be 2 times 2, that's 4, plus 6, that's 10. Here I'm going to get 6 times 2, which is 12, plus 2 is 14. So all of a sudden, oh look, doesn't look too good now. Now we're going to put 2 in here. So I'm going to get 2 plus 3 is 5. Remembering I'm doing bid maths, I'm doing what's inside my brackets first. 2 plus 3 is 5. 5 times 2 is 10. Okay, these two look promising. Finally, I'm going to be putting 2 into this position. So I'm going to get a times 2, that's 16. Okay, so all of a sudden, we can start eliminating some things. So right here, I've gotten 14, and I've gotten 16. So obviously, this and these, they're not equivalent expressions because they've given me different results. Now, so far, these 10s look pretty promising because they're the same. So maybe 2a plus 6 and 2a plus 3 are equivalent expressions. Let's now do the final one to see if this seals the deal. So let's now give those a go. So I'm going to be putting in 3 into my a position. 2 times 3, that's 6, and 6 plus 6 is 12. Now, I know this isn't going to work, but let's just do it anyway. 6 times 3, that's 18, plus 2 is 20. Here I'm going to get a 3 into this position. So 3 plus 3, that's 6. 6 times 2 is 12. Looking good. And then finally, I'm going to be putting a 3 here. 8 times 3, that's 24. And obviously, these are different. Right here, this 24 and this 20. But if you look here, if we look at these values here, all these values are the same as all these values, which means this and this are equivalent expressions because regardless of what number I substitute in, I'm always getting the same answer out. So I could say here that 2a plus 6 and 2a plus 3 are equivalent. So 2a plus 6 and 2a plus 3 are both equivalent expressions. Let me write that last thing down there. Equivalent expressions. Now that makes sense because we know our distributive law tells us that I could actually go 2 times a and 2 times 3, right? 2 times a is 2a. 2 times 3 is 6 plus 6, and 2a plus 6, they're the same there. So that's kind of another way of proving that they're equivalent. But again, this lesson is all about showing you how we can use substitution to prove whether or not expressions are equivalent. Now it's your turn to give this a go. So I want you to pause the video and see if you can answer this question. So you're trying to figure out which of these expressions are equivalent, if any. So pause the video and give it a go. I'll now quickly run through the answers. So let's begin by putting down all my expressions down on this side. So I have 3x plus 4, I have 8 minus x, and I have 2x plus 4 plus x. Then I'm going to say I have x equals 1, x equals 2, and x equals 3. Now it's just a matter of substituting in your values and seeing which ones are going to be equal to each other. So let's begin with x equals 1. So I'm going to get 3 times 1, so it's going to be 7. This one's going to be 7, and this one's going to be 2 plus 4 is 6, plus 1 is 7. So this is looking pretty good. Now next is 2. 3 times 2 is 6, plus 4 is 10. Here I'm going to get 8 minus 2, which is 6. So that's not too good. And then over here I'm going to get 2 times 2 is 4, plus 4 is 8, plus 2 is 10. Then I'm going to get x equals 3, so I'm putting in 3 into all my x's. I'm getting 3 times 3 is 9, plus 4 is 13. Here I'm getting 8 minus x, so 8 minus 3, so that's 5. And then lastly, I'm getting 2 times 3 is 6, plus 4 is 10, plus 3 is 13. So as you can see, all of these and all of these are giving me the same answers. So therefore, this and this are equivalent expressions. So I would say 3x plus 4 and 2x plus 4 plus x are equivalent expressions. Perfect. And again, if you wanted to cheat a little bit, you could have gone, well, 2x plus x, that's 3x. Then I have this plus 4. So it's going to be 3x plus 4, 3x plus 4, 3x plus 4. They're the same. Therefore, they have to be equivalent. But again, we're going to be doing that in the next lesson. In this lesson, you just need to be comfortable with the idea of substituting values into expressions and realizing that if I can substitute a number in, and regardless of what that number is, I'm always getting the same result out for a couple of expressions, that means they're going to be equivalent expressions. Perfect. Let's now review what we've learned in this lesson, which has been about equivalent expressions. Our learning objectives were to know what it means for two expressions to be equivalent. So hopefully you do know what it means for two expressions to be equivalent. And secondly, to be able to determine whether two expressions are equivalent using substitution. So hopefully you're comfortable with both of those ideas. You are now expected to finish your homework, which has been allocated for this topic. Good luck.